Hello everyone, I'm Himanshu Vasnani from Department of Mechanical Engineering. Today I welcome studying unit number 1 and in the lecture series today we are studying lecture number 3. The topic is type of defects and discontinuities in non-necessary evaluation and testing. So the objective for today's lecture is to have a basic understanding of types of defects and discontinuities and to know various factors influencing it. Outcome will be we will be able to understand various types and defects and types of defects and discontinuities in the materials, and students to understand the various factors influencing it. So the defects in materials. Normally, you can say that these defects can be called as volumetric defects that can be described in three dimensions or in a volume of different types of volumetric defects like porosity, shrinkage, holes or voids, corrosion thinning, corrosion pitting, inclusions. I will explain you all these things in the coming in this lecture only, that how this porosity holes that you see, shrinkage, the volume get decreased on cooling, holes, voids, corrosion thinning, corrosion pitting, inclusion. I'll tell you all these things. Now the planar defect. Now planar defects, these type of defects are thin in one dimension but larger in the other dimension. Some of them are seams, lamination, the lack of bonding, forging or rolling lap, hold shut, heat cracks, heat treatment cracks, grinding cracks, fatigue cracks, stress proofing cracks, welding cracks, incomplete penetration, brazing rebound. These all will be discussed with you one by one. Okay, these all will be discussed with you one by one. We will be discussing all these kind of defects and what they actually look like. I will give you a small picture along with them, whatever possible with us, and I will show you that how these cracks or these defects look like. Okay, so starting with again, then surface defects. Okay, these are surface defects can be interior defects or it can be exterior defects, and normally these kinds of methods are used for the detection, like visual inspection, like you can say compare with the duplicate part, maybe replica part, or magnetic particle inspection, ultrasonic testing inspection. So these all are the methods for detecting this surface defects, but this we will study later on, these how to find out those defects. Yeah, right now we are more concerned with the various defects, because unless and until we are not able to find out that what kind of defect is it, how will we able to suggest some you can say solution. So defect and discontinuities. The aim of the non-destructive inspection is to determine if the object being inspected is to be accepted or rejected. Okay. Uh, I have discussed with you in earlier lecture also that the major aim of our NDT is to determine object. We should be, if any flaw is there, that flaw should be accepted or rejected. And if during the inspection, if the inspector or the, you can say, whoever is inspecting things is just for discontinuities in the object, identifies their nature and size, then those discontinuities are evaluated according to an acceptance criterion to determine if they are considered to be defects or and rejected. Okay, if defect is there, then the object will be this simple as that. Okay, so uh, there are some definitions that you should understand: the defect and discontinuity. Discontinuity is defined as the imperfection or interruption in the normal physical characteristics or structure of an object, like a crack or porosity or inhomogeneity. Like you can say that you can say the there is some difference in the physical characteristics that you find out is discontinuity. Other hand, you can say defect is defined as a flaw that is by nature or accumulated in fact render a part or product unable to meet minimum applicable acceptance standards or specifications. Okay, so and if defect is there, then rejectability can be there. Now, defect is something like you are doing casting and the casting doesn't flow to the end, or you can say during casting the gases can't escape outside due to the interaction between both the materials. The hot gases evolve during casting process. They don't go out outside, so it will create a defect inside. Okay, so these are two different terms that you can easily you should understand that while inspecting things. Okay, it is a defect or it is a discontinuity. Now there is a major link between discontinuity and defect that you should understand, that a discontinuity is not necessarily a defect. Okay, a defect is rejectable, but a discontinuity is not necessarily a defect. Any imperfection that is found by the inspector is called a discontinuity. Okay, until it get identified or evaluated as to the effect that it will have on the service of the part to the requirements of the inspection. Okay, means that if there is some issue or imperfection that is found out during inspection, it if it can be repaired, then it's okay. If it can be serviced, then it's okay. And after servicing, if it is meeting the requirements of the working, then it's okay. Okay. And a certain discontinuity will be considered a defect in some cases and not a defect in some other cases, because the definition of defect changes with the type of component, its construction, its materials, its specification of codes being used. If it is, if can it can be improved, if the component can be, you can say, add on with some additional material and it can be recovered, then it is not a defect. If it cannot be recovered, then it is a defect. Okay. The types of discontinuities, majorly that we should know, that normal discontinuities into four, they are divided into four groups: inherent discontinuities, primary processing discontinuities or secondary processing discontinuities, and service discontinuities. Okay, we will discuss all these four categories and one by one. Okay, so let's start with the inherent discontinuities. This group refers to the discontinuities that originate during the initial casting process, when the metal is casted into ignores for further processing. And also it includes the discontinuities that are produced when metal is casted as parts of any given sheet. Understood? During casting, when the metal is melted into molten state at a particular temperature, the temperature varies from material to material. Okay, like for aluminum, you can say 800 degrees Celsius is the melting point, where it will completely change into melting molten state. Uh, when the casting is done, okay, at that time, if some discontinuity is there, okay, it can be removed by, you can say, through the uh, by removing the, or by chopping the ignorts, but still due to some issue they remain there. Okay, and these, during the whole manufacturing process, they create issues. So these are inherent discontinuities. This have came only when the, at the initial stage only, when the part was being produced. These are inherent discontinuities. So during the whole manufacturing process, they remain there. Okay. So we should understand that, like some of these are cold shut. Now cold shut usually it occurs during the casting of parts because of imperfect fusion between two streams of molten metal that converged together. Now, what happens that key, uh, when you are casting, okay, you normally what you do that you try to make an alloy. You try to mix two metals and found out a new metal. And if there is some imperfect fusion at that time, what happens that on the surface of the casted material or on the material, you can see that there is a cold shut. Okay, it can be an interrupted casting. Okay, and you can easily see that there is a difference between both the material. It can be seen very easily. That is cold shut. Okay, imperfect fusion between two streams of molten metal. It could be on the surface or subsurface. It could be attributed to sluggish molten metal, surging or interruption when pouring, or any factor that prevents the fusion of two meeting streams. Why it happens? Because somehow when we are making alloys, either the temperatures might have not reached so that the proper mixing is possible, or if you are applying one more surface at that time also, if proper condition doesn't meet, then also it lead to cold shut. Okay, so basically it can be seen on the surface or subsurface. Okay, next we go further, then we go with the pipe. In the pipe, as it is shown in the diagram, uh, you can see that there is a diagram showing bar rolled from ignite. So what happens that during solidification of the molten material, it shrinks, causing an inverted cone-shaped cavity in the top of the ignite. During solidification of the molten metal, it shrinks, causing an inverted cone shaped cavity in the top of the ignite. Okay, like suppose in the you are casting, you are pouring a molten metal, and after pouring you feel that it is complete, but after solidification it is causing an inverted cone. Okay, it is a kind of you can say discontinuity, because something is not complete and this it will be a discontinuity. It could be on the surface or subsurface. Yes, if it is defect, if the defective region is not cut out properly for further processing, it will end up in the final product as an elongated subsurface discontinuity, right? Why? Because suppose if you are making further rolling or forging process, so what happens? The metal is missing. There is sign of discontinuity, and at that time, what happens that the final product will, you can say, it will get disturbed, or it will, you can say, you can say, the surface will not be that supportive as all over the workpiece. So also when pipe could occur during extrusion, when the oxide surface of the billet flows inwards towards the center of the extruded part. While also doing extrusion process, also these kind of discontinuities happens like pipe. So what we can do that when there's such kind of discontinuity is occurring, so the area from which this pipe is showing, we can easily remove that area. We can simple cut that area so that this deformation or this discontinuity is not affecting the manufacturing or processing of the remaining part of the casting. Okay, see this is these are inherent discontinuities, cold shut and pipe. So this what happens that during casting these problems occur, but if it can be removed at earlier stage only, then the problems that could arise further after processing, they can be stopped. Okay, then shrinkage cavities. Now shrinkage cavities, what are these? These are subsurface discontinuities that are found in casted parts. Okay, they are caused by lack of enough molten metal to fill the space created by shrinkage. Now, you have also listened about, you can say, casting defects. So one of the defect is shrinkage defect. In that case, like that only, there is shrinkage cavities. What happens that if you know that the workpiece on cooling, they shrink. Okay, So what happens that while shrinking, uh, if uneven, you can say cooling of surface takes place, then these kind of shrinkage cavities they come. Okay, because what happens that if you are not able to fill enough molten material while casting, okay, in the cavity, so these kind of shrinkage defects they occur on the casting. Like pipe also, what happens is that the material get adjusted inside the cavity and on the top a pipe comes. Okay, so this is due to some you can say negligence while casting. Then here also in the cavities, these are found due to lack of enough molten metal. Okay, to that could have filled the space inside the cavity. Okay, now next if we go further, then we have with us micro shrinkage cavity. Now these kind of micro shrinkage cavities are some aggregates of subsurface discontinuities that are found in casted parts. They usually close bound to the gate, okay, and they occur if metal there at the gate solidifies while some of the metal beneath is still molten. Now what happens that you can say that while casting, okay, if while pouring molten metal inside the cavity, by mistake, if at the gate uh, some metal solidifies, okay, and what happens that that solidified metal is carried further, so this also lead to some discontinuity. Also, micro shrinkage could be found deeper in the part where molten metal enters the light section into heavy section where metal could solidify in the light section before the heavy section. That is what I'm saying. That is what I'm saying. That uh, after casting you will see that there was some material that was earlier you can say uh, solidified. So normally they are found at the bottom beneath the molten material because where they will go. This is it is shrinked earlier that it will automatically assemble at the bottom. This overall will affect or create a discontinuity which will affect the surface of the material of the workpiece prepared. So this is also not acceptable. Then hot tears occurs when low melting point material segregates during the you can say solidification and thus when tried to shrink during solidification try to shrink during solidification cracks and tears will develop because the surrounding material has already been solidified. See, short tears are very common. Okay, and these happen during solidification only. Okay, and you understand that uh, the surrounding material, if is already solidified, and if they try to solidify after that, then these are developed. If the material nearby already solidified and afterwards some or more solidification takes place, then this kind of issues come. Hot tears. You can see hot tears is also happen at a joining of thin section with larger sections because what happens that some solidification takes faster at thinner and some take after that. So what happens that due to the difference in timing of solidification, thus hot tears they develop there. Okay. Now blowholes and porosity. Now boreholes and porosity are small rounded cavities found at the surface or near surface of casting. and they are caused by the entrapped gas that could not escape during solidification. Blowholes are caused by gases released from the mold itself, and porosity is caused by the gases entrapped in the molten metal internal gases. See, in the blowholes, what happens that I can say while uh, see, we all know that uh, when you are melting a material in the furnace, okay, so when you are melting the material, uh, it is done at a particular temperature. And while preparing casting, what you do, you create a cavity first, and then you try to put that, you can say, cavity. Sorry, put that material, molten material, in that cavity, right? So when you are trying to put that material, molten material, in the cavity, two kinds of things happen. When you are uh, when you are pouring the materials, what happens that gases are evolved when your molten metal gets in touch with the casting sand. Okay, because apart from sand, some kind of additives are added, and these additives, when get reacted with, you can say, molten metal, then some kind of gases are evolved. And if those gases are readily released outside, readily allowed to escape during solidification, then there are no issues. But if those gases are not allowed to escape, they are trapped inside, then they lead to blowholes and porosity. Then they lead to blowholes and porosity. And this, uh, you can say, this issue is very common. This issue is very common. Nobody can, but you can just make arrangements so that such issues cannot come. If your arrangements are better, then these gas pockets will readily get released and no such blowholes or porosity will come in between. Then non-metallic inclusions. Non-metallic or slag inclusions, these are usually oxides or sulfides or silicates that remain with the mortal metal during original casting. Uh, See why it is different. You can see some kind of patches that has been included in the casting. The properties of those inclusions are different from the metal, and usually they have irregular shapes and discontinuities nature. Therefore, they serve as stress resistors that limit the ability of the material to withstand stress. Okay, now segregation. Segregation is also, you can say, one of the important topic to understand. Okay, segregation is localized differences in material composition and thus mechanical properties caused by the concentration of some alloying elements in limited areas. Okay, means if you are making a and if there is you know, and you find out that at some point the materials have mixed more and at some point materials have mixed less, so there is a difference in the material composition, so that difference composition is found in as a segregation. These compositional differences may be equalized during subsequent hot working, but some still remain. See, hot working means if you are heating the material to a particular temperature and then allow it to cooling it at that time, making some changes. So uh, deformation of shape may change place. The atoms inside or the grains inside may also gain some heat, and automatically they can improve their properties. So while hot working, these issues they can be improved, but they cannot be completely removed. Okay, but they cannot be completely removed. They are still remaining in there. Then primary processing discontinuities. These also we should. Till now we have been studying about only inherent discontinuities. Now we'll go with the primary processing discontinuities. Now this group refers to the discontinuities that originate during cold forming process or hot forming process, like in extrusion, forging, rolling, drawing, welding. You might have listened about all these processes. I'll give you a small idea. Forging means heating the material to a particular temperature and then so that it is not doesn't get melted, it just get hot. And at that time hitting with a hammer or some instrument to get its new shape, that is forging. Rolling means heating the material to a particular temperature and then give it a proper shape, a circular shape, that is rolling. Then drawing, heating the material and passing through a particular amount of dies so that proper amount of you can say wire can be drawn or some tube can be drawn with that. Welding is a kind of a process in which you try to join two parts together or two or more parts together with the help of a filler material and fusion process. Okay. So all some of the inherent properties in the material propagate and become significant also. The inherent properties that we did, if these are more problematic, then it will be called as a defect and it will be the part will be rejected. If not, then these are somehow allowed. Okay. Now seams. Seams are somehow really important. Why? Because while going for rolling process or while going for drawing process, drawing can be of tube or of wire depending upon the demand, whatever you are drawing. So seams are elongated surface discontinuities that occur in bars during rolling, or drawing operation. Okay. On the surface, you can feel this kind of discontinuity. Okay. Why it happens that they result due to the underfilled areas that are closed shut during okay. Now these areas, when some molten metal comes, they react and they uh, at that point some amount of reaction is there and some released, and those underfilled areas may result because of blowholes or cracks in the material. Okay, you will find that there will be some kind of blowhole or a crack on the surface of the material, and they also result from the use of you can say dyes which are not properly maintained or not properly lubricated or which have a bigger size than the requirement. Okay, so on the surface you can see seams that may look like it is a kind of a blowhole or a kind of a crack. But normally when you draw bars while rolling or while drawing process, maybe in the tube drawing, you will find that this kind of defect on the surface. Then lamination. Lamination, you all understand the word of lamination, a layer. So laminations are thin, flat subsurface separations that are parallel to the surface of plates. They may result from inherent discontinuities like in pipe inclusions, porosity that are flattened during the rolling process. Okay, because you know that uh, you will see a kind of a separation on the surface, and you will say that some kind of layer is coming out. That is lamination defect. Process discontinuity. Then stringers. Stringers are elongated subsurface discontinuities that are found in bars. They run in the axial direction and they result from the flattening and lengthening of non-metallic inclusion during the lowering process. You all understand that apart from the previous seams that is normally found in bars, but there is also some kind of discontinuity that you can see in the axial direction along the axis. So these stringers are there. And why they happen? Because when you want unnecessary lengthening and flattening of such kind during the rolling process, then these issues come. Then cupping, as the name says, cupping. So it is a subsurface discontinuity that may occur in bars during the extrusion or severe cold drawing. Cold drawing means without heating the material, you are just uh, trying to withdraw it. It is a series of cone-shaped internal ruptures that happen because of internal interior of the material cannot flow as fast as the surface where that cause stress buildup and thus rupture. Means our cupping this problem, this gives also rupturing. So you understand that this discontinuity while inspection if found that how if it can affect the product, the final product. So this subsurface discontinuity shall be removed in the bars while going for extrusion or cold drawing process. Okay, then cooling cracks. You might have listened about cracks earlier also. So you understand that cracks, if there, then they should be avoided because these are these may be problematic for short time also, and if avoided, these may create negative effects on future basis. So cooling cracks may occur on the surface of bars after rolling operation due to stress developed by uneven cooling. You understand that bars they go for rolling operation bars they go for rolling operation, then you should know that while cooling there may be some uneven cooling, and at that time these kind of cooling cracks they occur on the surface, and like seams also they occur on the axial direction, and but they do not have surface oxidation with them. Then forging and rolling laps also. Like in the first diagram, you see the too much metal excess squeezed and out of flow, and in the next you can see lap resulting when about lip is folded over and forced back into the bar and subsequent parts. As you all can see that these laps are elongated surface discontinuities that occurs during rolling and forging due to presence of some excessive material. Well, if you are trying to squeeze material and if material is excess, then it will show automatically that this is excess. This may result because oversized blank or improper handling of the material in the die. In the die, if properly material is not handled, then if excess material is entered, then where it will adjust, it will show in the form of lap only. Okay, so this you should you can say understand, and uh, moreover, uh, this lap is very common. This kind of defect is very common. This continuity is very common. This is a kind of surface discontinuity, if you understand. Now we'll go with the various MCQs in it, and the MCQs are like this. Like in non-destructive evaluation and testing, it is a kind of a discontinuity that must be investigated to see if it is rejectable. For example, porosity in a weld or metal weld. I have also discussed with you in the starting only that if anything is rejectable, then it is a kind of a flaw. Indications are different things. Some indications give that it is It may be true indication or it may be false indication. But flaws, it is a kind of a discontinuity that must be rejectable. Okay, this is the flaw. Then out of the various defects found in the material, these type of defects are generally observed exterior and interior of the surface of the workpiece. Now, what does this mean? I told you in the starting of the slides only that if you found something on the surface, okay, and you can see on the exterior and interior of the workpiece, then these are called as surface defects. Now, in this, it is a flaw that is rejectable, that it does not meet acceptance criteria. The after reading the slides only, you can understand this is a kind of a defect. Okay, a defect can be removed or it can be repaired. Okay. Now, discontinuity is defined as the imperfection or interruption in the normal physical or structure of an object. Is it true or false? Understand a term. Is it kind defined as imperfection or interruption in the normal physical characteristic or structure of an object? It is true. It is true. Okay. Now, inherent discontinuities refers to the discontinuities that originate during the initial casting process. Go in the name inherent initial casting process. It's true. When the metal get cast into ignorance of other process, it's true. Okay, remember these things. Inherent initial casting process, initial inherent discontinuities. Right. Now, sixth case occurs usually during the casting of the parts because of imperfect fusion between two streams of molten metal that converged together. I repeat once again, then you will understand. Okay. It occurs usually during the casting of parts because of imperfect fusion. Remember inherent discontinuities? This line came from there because of imperfect fusion between two streams of molten metal that converge together. Cold shut. I taught you this in inherent discontinuities. Okay, cold shut. When during solidification of the molten metal, causing inverted cone shaped defect in the top of the ignot. Very easy. You remember we had a good discussion on this topic, right? It could be on the surface of surface pipe. Pipe. We had a good discussion on this. Okay. Then the next question: shrinkage cavities are subsurface discontinuities that are found in casted parts. They are caused by the lack of enough molten metal to fill the space created by shrinkage, similar to pipe on an ignot. It is true. If proper molten metal is not supplied, then what it will do? It will go for shrinkage cavities. And this shrinkage cavities, they will cause some discontinuities. And these discontinuities should not or not allowed. So it is true. Okay, shrinkage cavities. Understood? Now these occur when low melting points material segregate during solidification and thus when they try to shrink during solidification, cracks and tears will develop because of the surrounding material has already solidified. I gave you this diagram, round diagram, center, some cracks were there. Remember this hot tears. Okay, the surrounding areas uh, solidifies faster and then the nearby closer areas then they try to solidify so hot tears they occur. Now these are small rounded active cavities that are found on the surface or near surface of casting and they are caused by the entrapped gases that could not escape during solidification. So that means blowholes and porosity. Remember, I told you during casting if some kind of you can say uh, reaction takes place, gases are evolved. If gases get escape easily, then no issue. But during casting, if while pouring the metal, if gases not able to escape, then lead to these kind of defects, blowhole and porosity. So these are the references which you can study and which you can see for reference, and these are good books, and they are listed only for your benefit. So if you want to get some more knowledge, then read these books and get the benefit. So for now, I thank you all for listening to me and having me here. And once again, uh, one important thing that try to understand things by looking at the diagrams also, which will be helpful to you. Okay, and refer these books. Thank you.